if the technology is not there to have the numbers, the measurements, then estimates is what we fall back to. And that's okay. I think we need to accept the inaccuracy. We need to find what's good enough.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software.
Hello, and welcome to the Week in Green Software, TWiGS, where we break down the stories shaping sustainable software and greener computing. I'm Tzviya, and today I'm joined by Kate Goldingring, Niki Manoledaki, and Susannah Hill. Niki's joined us before, and this is Susannah's first time. Niki was on episode 37, which you can take a look at on the Green Variable website. And of course, you already know Kate. Niki and Susannah, would you please introduce yourselves? Go ahead, Niki.
Yeah, hi. Thank you for having me on the podcast. I'm Niki. I'm a staff engineer at Grafana Labs, where I monitor our cloud infrastructure's cost, energy, and carbon. I'm also active in the CNCF as an environmental sustainability advocate, and really happy to be here.
Thanks for being here. Susannah, go ahead.
Well, thanks for having me. I'm really happy to have my first appearance. Big fan, long-time listener, first-time caller. I am a California-based sustainable computing consultant. I founded the nonprofit website Cloud Sustainability Watch, which is just a big directory of green software resources on the web. And I help non-tech companies to try to figure out their digital emissions. And I work on the W3C Web Sustainability Group with Tzviya.
Yeah, it's so nice to see you in person, Susannah, all of you in person. We are all recording together from New York City after an amazing conference, Green Iron New York, together. This week, we'll be diving into some of the main talks of the conference, where we each presented a little bit on various topics from green software, tooling, web standards. And we're going to each sum up our talks a little bit and dive in deeper into the main topic of the conference, which was sustainability and AI, how we're balancing the two. I'm just going to do a little bit of my take first. The main topic of the conference was sustainability and AI, how we're balancing sustainability and AI, in particular generative AI. We're past the point of no return with sustainability. And by that I mean, we're past the point of no return with generative AI, by which I mean there's no pulling it back. I used to work with somebody who said you can't put the toothpaste back in the tube. So how do we move forward? I think when Gael introduced this at the beginning, he said to us, there's no telling people they can't use AI anymore. So now we have to talk about how we move forward. And with that, I want to give a big call out to Gael and Nolan, the main organizers of the conference, who did an outstanding job getting phenomenal speakers and psyching us all up for this really exciting conference. So we're really at a critical point here. We're at a critical point with climate justice, we're at a critical point with sustainability, we're at a critical point with AI. So what do we do? One of the things that spoke to me most was Gael's recommendation that we ask for help, which is not something we often hear at a tech conference, even though we all really do need help. So there's a lot of help that we can ask for. There's calls to action from a technical perspective, which I think Niki will speak about. There's a call to action from an activism perspective, and we're going to dive into some of that. Kate, do you want to give a little bit of summary with the calls to action from a civic perspective?
Yeah, I think one thing that Gael did really well with this conference is the lineup. So for day 2 of the conference, that's when all the talks are, and it kicked off with Mashika Allgood right after Gael's introduction. And she talked about how AI is creating modern 21st century sacrifice zones, which was really interesting and really focused on the fact that these data centers are going to highly resourced areas that have already good infrastructure around water access and electricity. And that's oftentimes huge cities in the US. And from a historical standpoint, sacrifice zones came out of the New Deal and had a lot of redlining associated with them, and were in predominantly underprivileged and underserved and oftentimes Black communities. And it was really interesting, her painting that picture and how it's mapped to today, and pointing out the fact that we are sacrificing people for AI, and we need to ask ourselves, is this worth it? And it was a really powerful talk, and I've called out some of the protesting communities are doing around, I don't want AI in my community, because we hear that it builds jobs, but a lot of those aren't long term, and it's not helping those economies, rather it's sometimes hindering them. And most recently in Utah, there's a data center. There's been protesting from local community members to deny water rights access because Salt Lake already is really short on water and is becoming an environmental hazard because as it gets lower, there's actually an arsenic risk to air pollution in that community. So that's one to stay tuned into to see if that data center ultimately gets approved or not. And it was just to kick off a conference that way, really reminded every presenter to follow her, to ask constantly, why are we using this and how can we use it more sustainably, or how can we not use it at all? And right after her, Jonathan Gilmore presented from the Impact Project, and he dove even deeper into some of community movements around AI and data centers and really paying attention to where we're putting these data centers.
Yeah, I'll just add that all of the slides will be available on the Green.io website. I think today some videos of the sessions will be available if people pre-recorded them. I did not pre-record my session, I confess. And it was really interesting how both Mashika and Jonathan spoke about Utah. I had no idea about the arsenic, which is just absolutely terrifying. And that kind of leads also into Shiloh Wren, and I think Susannah really wanted to comment on some of Shiloh's previous research about water. He's one of the leading researchers on water and data centers.
Before we jump to Shiloh, I do want to hear Susannah's thoughts on, in general, data centers huddling around big cities, because I know you're in SF. San Francisco, and there are huge data centers there, and you're already seeing the impact and air quality with that.
Yeah, it's an interesting thing. We live in one of the most expensive real estate markets you could think of, and it's Silicon Valley. So there have been data centers since the invention of data centers, and I think for a long period of time, they weren't a particular problem. They were like any other sort of an industrial site. But as AI came online, it was coming online first there. And what happens is when you build a data center or you build any industrial site, it's very simple to add diesel generators as backup. The permitting for this is just dead easy because every industrial site needs backup, and particularly in California where we get these rolling blackouts, right? So, but what happens is if there's limited power and the AI demand is going up and up, they start running these diesel generators for much more than backup. It's for augmenting their power. And so they're running 300, 400 hours a year. And it's like the number 2, number 3 cluster of data centers in the country or the world. It's a lot of data centers. So the air quality in Silicon Valley in San Mateo County, where I live, has gotten much, much worse. Now, this is California. We're the people who brought you catalytic converters and emissions from cars being tightly controlled. And we watch our air quality. And so the Bay Area Air Quality Commission is aware that the PM 2.5 nasty diesel fumes are in the air, and it's getting much, much worse for everybody in the entire basin. And nobody's really talking about it. Nobody's doing much of anything, but Mashika Allgood lives down the street from me. She walks around with an air purifier, right? Because she's aware of how this is all going. It's a nasty situation.
I think one thing that came up in a few of the talks is, who is this for? We talk about AI, and a lot of the companies that are hawking AI, I'll say for lack of a better word, have tried to sell it as something that's for the community, producing jobs, which we've seen doesn't actually pan out. But then the perspective has to be, who is AI for? Is this for, we're not building jobs, we're not building anything except AI. So does AI actually serve a purpose? And we have to think about, what is the purpose of generative AI? The tooling can be very productive, right? There's medical research sometimes, but why are we doing this, and who is it serving? And that was a question that was asked repeatedly throughout the day.
One thing that you mentioned about the having to have the diesel backup reminded me of Shiloh Wren's talk, where he talked about how we have these summer peaks and how do we adjust for that? Because do we need our energy infrastructure to be at our summer peak level year round? And is that what we need to build for all of our data centers? Or is there a way we can store energy? So he goes down this discussion of like, okay, let's store diesel, or we can have massive batteries, but how do we produce those and charge those? And then he kind of ended with, why don't we reduce the amount of energy we need by using power? And what if we store water instead? And I thought it was a really interesting, in my mind, I ended his talk with this imagery of massive water tanks sitting next to data centers. I don't know, did other people get that imagery from his talk at all?
Yeah.
Yeah, and it was interesting how your talk and his talk were kind of parallel, but you were talking about virtual things and he was talking about water.
The physical.
Physical.
Yeah. And I guess for people who weren't at the conference, I guess let me look up the title of Chalet's talk to be quite precise. His talk was Building Community Integrated AI Data Centers. And he talked about he talked about what is our limiting factor with AI? Is it electricity? And he questioned that, and he kind of said it might be water. And that was one of the takeaways I got from that talk. And my talk was about serverless technologies and how we need to be able to scale to zero when we're not running things. So it's the same idea of how do we scale up and scale down dynamically in very different contexts. But I'd love to hear more from you all about Chalet's talk and his previous work as well, because he's well known. And so we were very excited to get to speak in a lineup with him.
Yeah, following him for me was like, I don't know, following Jay Leno, and they're just a hack of a comedian. And it was 2.5 years ago at Santa Clara University that I first came across him at an environment conference, and he was speaking about his research on water. And he was the first guy out of the gate to talk about the enormous consumption of water that data centers are doing. And he was coming out with the often cited now research about how much water it is for a call or a query, and how it varies depending on how water starved a particular area of the globe is. And then everybody started talking about water, but he had moved on. And then he comes out with this incredible research about the billions of dollars of healthcare that is required to take care of all the people who are injured by the diesel fumes of living in Delaware and Maryland downwind from the Northern Virginia data center cluster. And your head explodes. He's just way ahead of all of us on these environmental impacts. His TED Talk, as was mentioned several times, is a wonderful way of that information.
Yeah, his TED Talk was the first exposure I had to understanding how our use of water, how AI's use of water is so important. So if you haven't seen his TED Talk, and we'll put a link to that in the show notes, I strongly recommend it. I think it's like there are a few key people that you need to follow to understand your world of sustainability, like the actual impact of data centers on the world. We mention Dr. Sasha Luciani all the time on our talk here. There are a few like buzzwords we have, like Jevons paradox, Dr. Sasha. I think we need to, buzz in Dr. Shiloh Wren more often, and maybe even have him as a guest. I've chatted with him on the phone, actually. Very exciting person to talk to. But yeah, his understanding of water and the effects that what we do have on water is fundamental. Nikki, did you want to say something?
I thought it was really interesting. He mentioned at the end of his talk, he mentioned load shifting, and that ties back to the other podcast episode I recorded with you on temporal and spatial load shifting. So shifting workloads when it's a better time for the grid, or in a location that is a better place with regard to carbon intensity. I heard a lot of people mentioning Sweden and the region in Sweden that a lot of cloud service providers have, where it's a famous region for having a better carbon intensity. I thought that was really interesting that he proposed that. I wanted to add, in my talk, I mentioned how we haven't quite figured out the carbon intensity of networking, which we don't necessarily think about. Like, we think about load shifting as a fix, but we haven't quite figured out how to do that and if it's really possible, if it's really the way. But I thought it was interesting. I think it's important to keep that conversation going. And
Yeah, I think.
Yeah. I think there are locations within North America, right? Montreal is the best within North America, and Oregon's the best within the U.S. You don't have to match your instance in Virginia, for heaven's sake.
Yes.
California also very good.
Except for the air quality.
Well, the externalities of it. Yeah, it's so hard.
Externalities exist everywhere.
Yeah.
Yes, of course. Do you want to talk for a
Speaking
minute,
of which.
Nikki, about your talk? Your talk was super exciting, and I have to say, I know nothing about Kepler, but I understood you.
Thank you. I'm glad that you understood me. I was managing kind of a high level and low level, balancing my topic to make it, I read a lot about science popularization and how to make really low level topics accessible to a wider population so that the message can be shared further. I think it's really important to do that. So my talk was about how to measure energy consumption at the kernel level, so at the kernel of a server, of a computer, and how to multiply that at scale. So it was about a tool called Kepler, which is an acronym for Kubernetes Efficient Power Level Exporter. And it's an open source tool that is part of the CNCF, the Cloud Native Computing Foundation, one of the largest organizations for open source software. We have over 200 tools donated to the CNCF. We have over 300,000 contributors. My talk was not only about, how this is used, it was also about the community around it and how we can innovate in the open to have more contribution and adoption for tooling, especially when it comes to this problem that is a very difficult problem to solve. The problem being, how do we measure energy consumption for CPUs, GPUs, potentially networking devices accurately at the kernel level so that we can aggregate that at the level of hundreds of nodes, which is typically what we find in the hyperscaler environments and what cloud users will deploy to. So it was a really interesting conversation we had earlier about estimates versus measurements and how specifications and having models that might not be accurate at the kernel level, how they can provide a feedback loop that is important to have in the first place so that we can make some optimizations. And when do we need estimates versus when do we need measurements? I thought, Tzviya, maybe you could talk more about that.
So one of the speakers toward the end of the day was Natalie Hollier, who's just started her own company. And I think Susannah can speak a little bit more about the company she's starting, but the point that she made that really stirred me is that all of these engineers are spending so much time perfecting metrics and not enough time putting metrics into action, not enough time on activism. And we talk a lot in the standards world about progress over perfection. And I work for the W3C, where we work on standards, and we're working on the Web Sustainability Guidelines. That is our motto, progress over perfection. And it just got me thinking about how much time we're spending on perfecting everything. And, I always say that we need to have standards so that we can measure things, so that we can report, so that we can do X, Y, Z. But maybe we're spending too much time perfecting these standards and we just have to do something. And it was kind of all coming together in my mind. And I think there are so many things that this tied up in my brain for me. I don't want to jump ahead because my mind is kind of spinning right now with all these ideas, but we'll talk about Sasha and Boris's talk about monitoring and the metrics that they're looking at. But we have to find a balance between finding the right metrics and perfecting the metrics, but also moving on to applying them. And when it is, balancing application and activism and how we can actually make these things usable in the real world. So I think that we should talk about the announcement that Sasha and Boris made. For those who are not familiar, Sasha Lucioni was with Hugging Face until just a few days ago. Boris, and I'm sure I'm going to mess up his last name, Gamazaichikov, was with Salesforce. They've left to form their own company called Sustainable AI. They're going to be working on both the research as well as tooling to support their research. And what they've realized is that research is great, but unless you can put it in the hands of users, it's really just research, which is exactly what I think the point of this conference was, right? We need to make a difference in the world. There has to be real impact in what we're doing. And I would love to hear all of your thoughts on this. Kate, go ahead.
I think one question that we had throughout the conference is how do we make progress when so much data is being obscured from us? We don't know how much these data centers are always emitting. It's really hard to measure. My company provides a serverless platform, and I would love to install Kepler on it and get some data and share that with customers, but we don't have a culture of transparency right now for platforms. And one thing that Dr. Sasha Lucioni mentioned was that she, as an academic, always felt like she needed to have the point of she needed to have the facts, the numbers, in order to feel comfortable then building solutions. And one question that was posed in the Q&A to them was, how are you going to provide measurement tools if we don't have precise numbers yet? And I think that was a question that really struck home for Dr. Lucioni, because I think that is the question that she grapples with a lot is, I want to make progress, but it's really hard for me from an academic standpoint to put out anything that's not precision. But I think that's what they're going to try and do, is they're going to try and make progress with the numbers and estimates that they have and share those tools and the ability to make some level of assessments now. And then as more data comes in, ground that in their tools and build upon that. And I thought that was freeing for me too, because I have that internal debate as well.
It was interesting to hear about this trade-off from them, and there are certain challenges with getting accurate numbers for GPUs, for CPUs, which are predominantly the two devices that we look at. What I wanted to highlight was we're all struggling with this trade-off of estimates versus measurements. For example, I've seen successful projects use estimates. I've also seen projects struggle and take a step back because these estimates were not valid enough. So I've seen with Kepler, for example, it's been used successfully by some of the European telco carriers who are driven to measure their carbon estimates due to EU policy. And we've seen, for example, Project Silva, which is a Linux Foundation Europe project that is led by some of these European telco carriers, and they use energy estimates to optimize the energy consumption of their tooling. And it was such a great example to see telco carriers come together and really put sustainability as one of their architectural pillars. And another case is CERN, the European Center for Nuclear Research at the Swiss and French border. They are famous for finding the God particle. They do incredible research, and they are trialing energy efficiency because they're coming into the high luminosity era in the next few years, which is going to increase their energy consumption, but they're trying to cap that because at the same time they have this sustainability KPIs. So they're managing a trade-off between estimates and measurements because they do have hard numbers to hit, but they also care about estimates so that they can optimize. And, if the technology is not there to have the numbers, the measurements, then the estimates is what we fall back to. And that's okay. I think we need to accept the inaccuracy, or we need to find something close to, so we need to find what's good enough. I think that's the conclusion.
Susannah, what about you?
The lack of data for everybody concerned is a problem. And when I say lack of data, what I mean is that nobody is able to understand what the impact of their own usage of any AI feature or AI model really is. When I did my talk, I was comparing the danger that we're putting ourselves in with the pollution and the usage of AI to people not having seatbelts, 50s and 60s. And when it became obvious that seatbelts were needed and that the auto industry wouldn't do it, there's tremendous pressure on the auto industry. And I think data is the missing piece. Visibility of the impact that we're creating when we go online is the reason why nobody's crying out for the tech industry to do better, like we called out for the auto industry to do better. And in the consulting that I do, I work with the end users, the customers of people who are deploying AI features into regular old cloud apps that used to not have AI, like Microsoft 365 or Canva. And they are beginning to sense, I read in the paper that AI is a big problem, but should I reduce my amount of chat GPT? And my thought is, well, it would be really awesome is if you went into work and started talking with the tech people there and asking if they're measuring the sustainability, the emissions of all of the online work that your company does. And if you're choosing which apps you're using based on their sustainability, because it's a big difference between a company that is taking some time and care to do a sustainable implementation of their AI, hosting it green, to using a smaller, more appropriate model, designing the user interface so they don't call the model as much. Such simple damn stuff. But even there's another data void, which Cloud Sustainability Watch tries to fill, which is even knowing that these are options that make a difference if you're a software designer. So people are concerned about AI, but they don't see the connection between going online and the diesel fumes that they're lighting up at the data center down the street and the water and methane consumption at the power plant in their region. And once they do that, I think there will be a lot of outcry for AI to be better and the industry to do better. But that's a data void, in addition to the one that we're talking about.
It brings to mind at my former employer, the travel app that we used would, when you book a flight, it would say this flight uses this many tons of carbon for this flight. And I never paid much attention to it, but it was there. It was always, making me feel guilty. But we don't have anything like that on websites, on anything. But when Green Pixie did their presentation for their green hosting software, I think it was James who was showing that, when they run Claude for their clients, they have a little tool that they added that shows how much carbon is being used, how much water is being used, how much it was GHG,
power,
water and power, right? Which I didn't think much of at the time. I was thinking, well, wouldn't it be awesome if they could reduce that? But if you have that thing making you feel guilty every time you run a query, that's great. At least you're aware of it. And, of course, I'm going to do a pitch for standards. This goes back to what we've all been talking about, estimates versus precise measurements. If we standardize on something, I said this in our last episode also, or maybe 2 episodes ago, we are at least all using the same units of measurements, and we can compare. Because if I'm trying to decide if I should use real company names, if company A and company B are measuring their GHG differently or their water differently, if one is using volume and one is using weight or whatever it is, then it's really hard for the average user to compare. So we don't even have the same types of measurements right now. We need to come to terms. We don't necessarily have to measure the same way. We do need to measure the same way. That's what I'm saying. We need to use this. It can be a competitive advantage if you measure in the same way. So you can say, I pollute less than you do. I'm waiting for people to realize that this is indeed a competitive advantage, but reporting is harder if you don't measure. It's all harder if you don't measure. And if we're going to have a widget that plugs into every browser, plugs into every AI query, you need to have something to measure. Progress over perfection again.
And this is James Hall, the Green Ops manager at Green Pixie, which is fantastic.
He was, absolutely.
And also, I think he was presenting with Will Tinney.
Absolutely. Thank you. I couldn't think of James's last name. Thanks for
no problem.
Thanks for pinch hitting.
And that number that they gave, so the kilowatt hours of your query, speaking of estimates versus measurements, I asked afterwards, how did you get that number? and it's a global average because they can't get granular. You don't know where your inferencing request is running when you use a huge provider like Claude. And so that's an estimate. Like, it would be nice to know if I live near Sweden, once again, shout out to Sweden, that, okay, maybe I'm being routed to that server and it's less energy intensive, or if I live near a plant that's more focused or that's powered by gas, that it would be more carbon intensive. But right now we just have those global averages, but it still gives you a sense of your impact.
And I'm not sure what he was saying. So if they're doing, sorry, Nick, if Green Pixie is doing a project with NTT and they know that the cloud is most likely running in the Japanese grid, then they do know the carbon intensity. So
yes.
Yeah.
If they're hosting their own, is NTT, what is NTT?
NTT is Nippon Telephone and Telegraph.
Okay.
Yeah.
But they're probably not hosting their own GPUs, right?
But probably the Claude instance is somewhere
nearby
in Japan.
So they can assume based on by averaging the energy sources of Japan, kind of get a sense of it, which I don't think they're doing yet, but that would be a cool optimization for them to basically geo-guess.
We talked a little bit.
Guess
I bet they geo-guess.
We talked a little bit about the billing model of Anthropic, which is with the Green Pixie folks. There's two general configurations. One is the global request. So Anthropic will query anywhere in the world, and that's cheaper versus the regional request, where you can you can set your request in a specific region, and that's more expensive. So there's actually the geolocation of where proprietary LLM requests are processed. That is a black box that unfortunately we don't have visibility on, which makes it harder to get accurate numbers. But with Lisa Pratico and with Casey Clark of Sustainable Architectures, we had a really interesting conversation on top-down versus bottom-up metrics, and how what we're talking about, even Green Pixie, they use NVML, which is an NVIDIA estimation model, so in for GPUs, and those are estimates, but those are bottom-up metrics. The top-down metrics are all of the carbon accounting numbers that we're talking about, and so we always have to choose which of these two directionally correct numbers we want to use. Do we need the top-down metrics or do we need the bottom-up metrics? And it really depends on what we're trying to achieve. Like, Green Pixie are creating a model for us to optimize, even if it's not the scientifically correct carbon accounting number, because we don't know where that Anthropic query is running, for example.
I'm a big fan of geoguessing
I
in
love
the work
that
that
term.
I do, because if an accounting firm is located in Chicago and they're running Zoom, I can pretty well guess that the co-locator that's running their Zoom session is going to be in Chicagoland. And so I think that what you're saying is absolutely right. And in a different circumstance it can be hand waved in order to get to the point that, hey, if you're using Zoom and they're using a co-locator, and by the way, the PUE of a co-locator versus like an AWS is not good at all, but Zoom uses co-locators. And you could get on Google Meet and better yet, turn off your video or have a phone call. I don't remember what those are. Anyway, the point is that for end users, that visibility into what it is that the Green Pixie's little counter can bring is really helpful, even if it isn't well done. I'm a big fan of geoguessing, which I'm now going to copyright.
It's just that we're hitting the limits of what's technically possible, and we have to be okay with that, because we literally don't have the ability to know what's happening behind, like under the hood, with some of these proprietary LLMs. So we're hitting the ceiling.
Some of it's hitting the limit technically. Some of it's, I think, one of my takeaways, we're hitting the limit technically, we're hitting the limit physically, and to some extent there's people not disclosing information. You touched on Lisa and Casey's talk. Well, Casey emceed the workshop day. Lisa spoke yesterday about sustainable architecture. She is participated in writing a long book about sustainability. I'm excited to get my copy. Susannah, you've worked with Lisa in the past. Do you want to, I think, do you want to touch on that?
I have not. I just vibed with Lisa hugely. I think we all did, both Lisa and Casey. The work they're doing at Sustainable Architectures is perhaps the most thankless in the green IT world, but their backgrounds are so impressive. They just have that kind of knowledge that's incredible. They're both architects and enterprise architects, which, just saying it, you start to fall asleep. But it's the most important work. And Lisa's talk, which was about how to really think about resource constraints and putting visibility into sustainability throughout the planning process in a corporate environment, was so necessary for thinking holistically. It was a great reminder there's no level of detail too detailed for us not to look at.
Oh my gosh.
I'm laughing because I did that kind of work for 8 years. It wasn't technically in sustainability. It was kind of in what my manager called the illities. It was like all the stuff that got overlooked. I was accessibility. I was toward the end of that job. Sustainability. I did a little bit of privacy work. I did all the stuff that people don't like to think about. And it was just like an exercise in evangelism. And don't forget, and like you do things like talk to the CTO one day, talk to the new developers the next day, talk to the product managers. And you're one person. And it's not, in most organizations, it's not actually enterprise architecture, it's one person who might sit in central architecture or enterprise architecture, but also often you're the first person to get laid off. And so it's a whole shift left thing that has to happen, and that's been so much of my career. And now it's not. I just help other people do that. But it's really important, and it's really thankless work, because most people, it's not the stuff you learn in school. I remember giving a presentation once called What You Did Not Learn in HTML School. And people loved the title, but it was like developers had never learned ARIA, which, if you come from the world of accessibility, is so upsetting. It's the most important part of accessibility, or one of the most important parts of accessibility. People don't even know what the accessibility tree is, and they are the ones creating websites. So that's my little accessibility pitch for today. Yeah, go ahead.
May I switch channels? Kate, I just want to talk about your talk.
Oh.
I thought what you were saying was so important, because getting AI inferences, in particular, in my opinion, into the right place where they do the least damage is so important, and designing them in a way that do the least damage. And as soon as you were talking about putting it in the edge and running it on web-based architecture, like, I didn't understand anything you were saying, but I understood what you were saying, because I'm not an engineer. And running, as soon as you said, well, we're going to put it in technologies that were designed for operating the web, that clicked, because the web is all about efficiency and speed and no bullshit ways of delivering what the end user wants, which is, I think, AI has gotten lost in a cornfield of over-engineering.
Yes.
And it was such a breath of fresh air. And your insights were, to me, just so new and fresh. Thank you for that.
I really love evangelizing WebAssembly, which is the technology you were mentioning, and serverless. And I'm a back-end engineer who's basically built off the back of web developers, in another word, because WebAssembly, like I mentioned in the talk, was built to be the second language of the web. But because the web is a browser, is this shared space for all applications, it has this really cool ability of being fast, small, and an isolated environment. And so what we've done with serverless technologies is bring WebAssembly to the server. So now you can run it in a cloud space and have really fast, isolated workloads. When you talk about inferencing, there's interesting stuff around WebAssembly and AI. That's not stuff I dive super deep into. I mentioned at the beginning of my talk, I think mine was one of the only talks that didn't dive super deep into AI. So I gave us a little bit of a break for a moment, but there is interesting work where people are putting together an entire LLM model and a tiny WebAssembly module and putting them in one package and putting them on edge servers. So you're packaging a model with its application and running it on the edge. So there's some interesting stuff that's happening with WebAssembly and AI, especially for like really small optimized things. In particular, people are even looking at this on like IoT devices. Yeah. So it's a really interesting area to explore when you want to think about doing processing where data is. So when you think about data gravity, there's a lot of interesting stuff happening there as well. Things that I've thought about in the past with like inferencing and serverless is I was at a startup Fermion that recently got acquired by Akamai for our serverless WebAssembly platform. And at Fermion, the way we tried to make inferencing more sustainable is that we queued inferencing requests. So instead of using more GPUs, we had a queuing algorithm that made it so that all inferencing requests from serverless applications would enter a queue to use the like few servers that we could afford as a startup, which is great. Like when you have a lower budget, you have to be smarter about it. So we were able to basically provide the service to people, but do it more efficiently with, instead of physically sharding GPUs, we time sharded GPUs with a queue. And that was one way we were able to kind of get a better bang for our buck with AI inferencing.
And Susannah's in awe.
I am in awe. It kind of sparks the kind of information that James Hall, and Will Tinney were talking about when they said that the work that they did around no, it wasn't them. It was a different Green Pixie presentation where they were talking about how they were trying to bring down the cost of using AI within ABB, and that they did it by building a lot of guardrails around the usage. And it's very similar to what you're describing, where they were trying to manage where requests were sent, how they were sent, qualifying which model they were sent to, all kinds of things that really echo what you just said. Yeah. And I am in awe.
And at the heart of it all is the software carbon intensity specification.
Yes, yeah.
Kevin Leslie.
Will you explain what SCI is if people don't know about it yet?
I was so
I'm sure
happy.
People on this podcast know what that is.
Yeah, I mean, the software carbon intensity specification is used to plug in the different factors needed to estimate or measure the carbon intensity of a software application. And maybe my talk would have made more sense after yours because you explained the SCI, and Kepler is used to measure the E in the SCI, the energy, the runtime energy consumption of the application. So I was so happy with the equations that you shared in your presentation.
Yeah, I think SCI maybe it should be like in the intro of every Green IO conference because it is that ISO standard that can ground some of the data we want to get from things. So I know for some people they'd heard it plenty, but I enjoy breaking it down for people who hadn't heard about it. And I had a few family members come to my talk, which was the first time I'd ever had family come to a talk I was giving. So I knew I had them at attention. I felt like they needed to understand SCI by the time they left. So I spent maybe too much time on SCI, but I think that was my goal.
Always time well spent.
Not everybody in the audience is on the technical side, so I think it was actually super. And it doesn't hurt to review for the people who know it well.
I love it.
And it is dead simple in concept.
Yes.
It's like, duh. But filling in the variables with the actual data.
It's very hard.
It was a great talk, Kate. I think there's only one talk that we didn't touch on. The last talk of the day was a little hopeful. It's about AI being used to actually measure heat risk in this warming world by Nada Tarhan. I hope I'm pronouncing her name correctly. I actually had to cut out before she finished, so I'm hoping somebody else can speak a little bit more about what she said.
I'm happy to talk a little bit about it. So Nada is a PhD student at MIT. She's actually graduating this week, so cheers to her. But she's heat map modeling using models that she's... and this was another part of estimating versus measuring, because what she does is she basically looks at the build materials and the layouts of cities and places her model on top of that, and she is estimating how over time these cities are going to get hotter and hotter. She had a huge focus on Phoenix, which we talk a lot about Phoenix in general. I feel like with the amount of water issues there and just general heat and putting data centers there, and now just city thermal heat mapping. And she also talked about Boston, where she lives. And using her model, she mapped out the potential future of possibilities. And what I thought was really interesting is she's partnering with lawyers at Harvard And they are now working with policymakers to bring them this information. And so I thought it was a really cool example of not only how you can use AI to actually benefit our future, but also how academic settings and partnerships like that can lead to policy changing and better potential futures. So it was a really exciting talk for me. And also, I just want to say, I think her slides were my favorite of the,
Those are cool.
Yeah, the ones I saw were very
they were just, it's so beautifully laid out, footnotes, all the resources you need. So I'm a big fan of Dr. Tarkins, for sure.
Thank you for
I-
summarizing that.
It would have been great if we had tackled her to make sure that she was using the most green hosted
Oh my
model
gosh.
that she could.
But,
Yeah, I wonder if MIT has their own GPUs, if they have their own lab, on site, or if what they do.
Well, W3C used to be part of MIT until a few years ago. I don't know.
Yeah.
I have some people I could reach out to and find out, but if they are hosted, it's not her part of MIT, it would be CSAIL, the Computer Science and Information Lab.
Yeah, the reason I was curious about it is because in a previous episode we talked about how is edge computing actually green?
Yes.
And it's very questionable whether it is because you don't usually get high utilization. But on universities, it's usually undoubtedly green.
Right.
Because they oftentimes do heat harvesting on universities where they have these servers set up, and that's used to like heat the buildings, and especially winters in Boston.
MIT is a very urban campus, though, so I'm not sure. Harvard more likely because
Yeah.
it has the quad and everything.
I'm-
But I'm totally hypothesizing. I don't
I'm an
know what I'm
MIT
talking-
alum, and you walk down the long corridors of those buildings to connect. If you don't want to go up into the freezing cold, you connect through the heat, and they actually do have what I would call, like, oh, golly, what's the word for this? Ugh, you're gonna have to cut this out. What is it when they have the neighborhood heating, where there's one heat source and they send the actual heated air around all the way around the neighborhood? What is that called?
I have no idea. That's really cool.
A zone heating neighborhood. And
I've
the
never
point
heard of
is, yes, they harvest the heat.
Okay.
That is really cool.
Wow. Well, do people have any final thoughts that they want to share about the day, about Green IO, about events coming up?
That's cool.
Well, with Green IO, the big beautiful thing about Green IO is the vibe that Gael creates, where everybody, we're fighting an uphill battle to be heard, to be relevant, to be impactful, and we all support one another. And it's a party, it's a class reunion, and it's great.
Yeah.
And it's a very heterogeneous group of people.
It is.
Absolutely.
Very diverse.
This is the only conference I've ever been to that has majority female speakers. I love it. You can see we are
Yeah.
vibing here. Let's talk about one upcoming event that I know about. I mentioned the paper, State of the Fossil-Free Internet, in my talk. The Green Web Foundation is hosting a session on May 27th to talk about State of the Fossil-Free Internet. You can sign up for it. We'll put a link in the show notes. And unless anybody else has...
Nikki, do
any-
you
Yeah,
have a-
my
Oh,
my
go
call
ahead.
to action is the
nice.
CNCF Environmental Sustainability Technical Community Group is reviving and rebuilding. So if anyone is interested in a space that is open source, focused on open source software and environmental sustainability, and they like to contribute, maybe vibe with I think it's mostly software engineers working in cloud computing. We have a lot of platform engineers. If that's your vibe, you're welcome to join us, and it would be great to have you and work together on building cool things
Great.
that make an impact.
And you'll put a link in the show notes too, please.
The only other thing I would add is I think the next Green IO is in December in Paris. Is that right? It's that the cadence, I think, maybe?
There's one in London.
There's one.
November, October.
October?
Okay.
Okay, we're all
Watch the-
very up to date on this.
Watch the Green IO website for upcoming conferences. Actually, I say that with the Green
Was that the
IO.
chart that Gael showed? Those were all Green IOs. They weren't
Yeah.
just FOSS. Okay, in that case, there's one in June somewhere. Even I saw that. There's
There
June,
is
July.
June 9th and 10th, Green IO Amsterdam coming up.
Wow.
And after that, July in Munich. Wow. Gael is
Keep
extremely
going.
busy. September in London. December, Paris. Stay tuned. Take a look at the greenio.tech website.
So the Green IO, London, and particularly Paris are huge. Hundreds of people.
Wow.
There's a real green software community
Well,
in those two countries.
that's exciting. Maybe I'll go to Paris.
Yeah.
Do it.
Or London. I've never been.
Really?
No.
Go. Enjoy. All right. Well, that's it for this week's TWiGS. It was really exciting recapping the Green Iron New York conference, and hopefully I'll see all of you soon.
Yeah.
Thanks for joining. Thank you, Kate, Niki, and Susannah, for a really great discussion. If you want to keep exploring, check the links that we mentioned in this week's show notes, and you can visit podcast.greensoftware.foundation to listen to more episodes of Environment Variables. See you all next week, and bye for now.
Bye, everyone.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.